Welcome to The Explainer. Today, we're going to unpack a huge idea, how computing went from being a thing, a box on your desk, to something more like a utility, just like the electricity or water that flows into your house.
Okay, so let's just dive right in with a question that might sound, well, a little weird at first. We think of water and electricity as these things that just appear, right? They flow into our homes from some massive invisible source. So what in the world does your laptop have to do with that?
Well, the answer's pretty mind-blowing when you think about it. Computing has quietly joined the ranks of the essential services we rely on every single day. The power to process information, it's now being organized and delivered just like those other traditional utilities. And this idea totally transforms how we think about tech. We're moving away from a world where we had to own all our computational power to a model where we just access it. It's not just a product anymore, it's a service, a fundamental part of our public infrastructure. For the longest time, society has been built on four big utilities: water, electricity, natural gas, and the phone network. But now, there's a fifth one in the mix. Computing is now considered just as essential. So this brings us to the official term, right? Utility computing. All it really means is offering up computational power as a metered service. You access what you need, when you need it, and you only pay for what you use, and you never have to think about where the actual servers are or who's keeping them running. It just works. But you gotta ask, why? Why did this shift even need to happen? Why did we need a computing utility to begin with? Well, it all boils down to one simple, relentless demand. The one question that has pushed decades of innovation is this one: how do we make stuff run faster? From massive scientific research projects to just streaming your favorite show, we have this insatiable need for more speed and more processing power. So, in the computing world, you've basically got three ways to answer that question. You can work harder, just buy faster, more expensive hardware. You can work smarter by writing better, more efficient code. Or, in this last one, get help. Oh man, this is the one that changed absolutely everything, using multiple computers to tackle a single task. Yeah, that simple idea of getting help from other computers, that's what laid the groundwork for this entire new utility. It meant we had to build a whole new kind of infrastructure. It all starts with this concept: distributed computing. And it's a really simple idea, but it's so powerful. Instead of having one giant, super expensive computer do all the heavy lifting, you just get a bunch of regular computers to link up and share the work. The first big step in making this a reality was something called cluster computing. Think of it like a team of sprinters, all in the same room, connected so they can work together as one single, incredibly fast runner. They're all in the same place, working on the same problem. Then, things got even bigger with grid computing. Okay, so if cluster computing is a team in one room, grid computing is like connecting all the best teams from all over the planet. You're taking resources from different universities, different companies, all over the world, and linking them into one massive shared pool of power. So what's the real difference here? Well, it's all about how tightly they're connected. Clusters are tightly coupled. Again, think of that team in one office, super coordinated. Grids are loosely coupled. That's more like a global freelance project, with different groups contributing their power when they can. So you have these foundational pieces, right? These digital power plants and transmission lines, the clusters and the grids. And all of that was setting the stage for the ultimate version of this whole utility idea, what we all now just call the cloud. The word cloud itself is really just a great metaphor, isn't it? It's a simple name for this unbelievably complex web of servers, data centers, and software that we tap into every day. It hides all the messy details, so we don't have to worry about what's going on behind the curtain. So what does the cloud actually do for us? Well, for one, it gives us a super simple way to get our hands on what feels like limitless computing power. We get massive scalability whenever we need it, and it's opened the door to totally new ways of delivering apps and services. So what is it that really makes the cloud, well, the cloud? We can actually break down its DNA, and we can do it with a really simple analogy using just three numbers: 1, 0, and infinity. First up, the number 1. This stands for the idea that the cloud looks like one single, unified system to you. It might be made up of thousands of servers all over the globe, but all that power is available to you in one integrated place. Next, we have 0, and 0 represents the goal of, you guessed it, zero management from your end. The system is smart enough to handle all the complicated stuff on its own, managing resources, fixing things when they break, so you can just focus on what you're trying to do.
And finally, infinity. This one's my favorite. It represents endless possibility, a seemingly infinite pool of resources. You get massive scale, always on availability, and incredible performance that you can dial up or down whenever you want.
So what does this all boil down to? Well, for you, the user, it means the tech just melts away. It becomes invisible. You just get the service you need right when you need it. And for a company or an organization, it's a launch pad for innovation, letting them deliver services at a scale that was unimaginable before.
So we end right back where we started, but with a new perspective. We've watched computing go from a physical box to an invisible force that flows to us over the internet. Now that computational power is delivered like electricity, it really makes you wonder, doesn't it? What essential service is next? What's going to be our sixth utility?